Welcome back. We are still doing magnetism. Don't forget to like our channel. It's called Study101. Share it with a friend. You feel free to like our videos. We are still continuing with magnetism, and right now we are going to look at sample questions. We are not looking at all the questions that can be asked, but we are just having a sample. The first thing is we should be comfortable with the definitions. Magnet. A magnet is a piece of metal that has got the ability to attract other magnetic materials. Magnetism, in our first video we said it is the force that enables a magnet to attract other magnetic materials. Magnetic materials are materials that can be attracted by a magnet. Non-magnetic materials are materials that cannot be attracted by a magnet. Magnetic lines of force are the lines that show the direction of the magnetic field. Magnetic field, this one we said it's the area in which a magnet exercises its force, or it is the area in which a magnet can attract magnetic materials. Magnetization is the process of making magnets, or it is the process of making a magnetic material gain magnetism, and demagnetization being the opposite of magnetization, it is the process of weakening a magnet, or it's the process of destroying a magnet, or it's the process of making a magnet lose its strength. Give examples of magnetic and non-magnetic materials. Let's begin with the magnetic materials. And with the magnetic materials, we are beginning with them. We are going to give the magnetic metals. Metals like iron, steel, nickel, alnico. Alnico is an alloy of aluminium and nickel. But aluminium is non-magnetic. When we go to the non-magnetic, we shall begin with aluminium, gold, copper, silver among the metals. So some metals are magnetic while others are non-magnetic. Then the rest of these other materials are non-magnetic materials like plastic, glass, rubber, wood, chalk, paper, cloth, and the rest. Why can't aluminium, or why can't gold, copper, or silver make a good magnet? They cannot make a good magnet because they are non-magnetic materials. Or you can say they cannot be attracted by a magnet. How are natural magnets different from artificial magnets? Natural, like I said, where we use natural, with natural, it exists on its own. Something that is natural exists on its own, and the one that is artificial is made by man. So natural magnets exist on their own, while artificial magnets are made by man. Number 5, in which way are permanent magnets different from temporary magnets? Permanent magnets retain their magnetism for a long period, while temporary magnets easily lose their magnetism. State the principle of magnetism. We have recited this many times in the previous videos. The principle states that unlike poles of magnets attract, while like poles repel. That's the principle, or we can call it the law of magnets or magnetism, and it is one of the properties. Then question number 7, state any 4 properties of magnets. I can begin with that one, which we call the principle. Unlike poles of magnets attract, while like poles repel. A freely suspended magnet rests in the north-south direction. Magnetism can pass through non-magnetic materials. Magnetism is concentrated at the poles. Magnets weaken with age. Broken pieces of magnets retain their north and south poles, and very many others. Question 8, identify the property of magnets used by sailors and pilots to locate direction. A freely suspended magnet rests in the north-south direction. In which direction does a freely suspended magnet rest? It rests in the north-south direction. We write north-south like this, north-south. Capital letter, hyphen in between. Describe the movement of magnetic lines of force of magnets. Magnetic lines of force of magnets run from the North Pole to the South Pole. So this number is featuring one of the properties. And in the earlier videos, I told you there is only one magnet that defies this property, and that magnet is the Earth. For it, the magnetic lines of force run from the South Pole to the North Pole. Why is the Earth called a magnet? The Earth is called a magnet because it has a North Pole and a South Pole. That's yet another property that is featured in this question. Then we move to this part which requires us to draw diagrams. Draw diagrams showing magnetic lines of force of these magnets. A horseshoe magnet and a bar magnet. This is a horseshoe magnet and this is a horseshoe magnet. This is the basic diagram. This is the simplest. And as you go on mastering the magnetic lines of force, you should be able to draw it this way. But this is the very basic one. You'll get your marks. Then the bar magnet, I also have two illustrations on the bar magnet. There's this first one. This one is the very basic one. Draw a box and then show the poles, and then one line of force passing above and one passing below. This is the basic one. As you go on mastering, you should be able to draw something like this. Draw diagrams showing the following properties of magnets or magnetism. The first one is magnetism can pass through non-magnetic materials. We have got two illustrations. These are the illustrations we used in our earlier video where we were showing the properties of magnets. This is the magnet. There's a non-magnetic material and a magnetic material below. So the magnet is attracting the nail through a piece of wood. It can be a cardboard, it can be a piece of paper, or any other thing which is non-magnetic. Then we also did this one, whereby the magnet was placed into the glass and it was attracting the nail from outside the glass. Magnetism is concentrated at the poles. Magnetism is stronger at the poles. This is the illustration. You choose any one of those magnets, whether the cylindrical magnet or the horseshoe or bar magnet. One of them, once nails are applied onto this magnet, you'll find that they will concentrate at the poles. A freely suspended magnet rests in the north-south direction. Our magnet is on the string and it is freely suspended. It will keep rotating, but the final resting, it will rest in the north-south direction. This one is the basic diagram, which is very simple. And as you keep mastering your diagrams, you should be able to draw something like that. The poles don't matter, the positioning of the poles don't matter, whether this is North Pole and this will be South Pole. Your paper, whoever is marking will award the mark. Like poles repel, then unlike poles attract. We are going to see this one in the same kit. Attraction. We said unlike poles attract. Unlike poles attract. South and north, there's attraction. The arrows should be there showing the magnetic lines of force. This one is still attraction. Then, like poles repel. North-north, repulsion. South-south, repulsion. You should be able to draw the arrows correctly to show the magnetic lines of force because they run from the North Pole to the South Pole. Identify one method of making magnets without using a permanent magnet. First of all, ask yourself, in which methods do we use a permanent magnet? That is the stroking method and induction method. So they are demanding for a method that requires you not to use a permanent magnet, and that is when we are using electricity, and that method is the electrical method. How can we make a temporary magnet? How can we make a temporary magnet without using a permanent magnet? Without using a permanent magnet, it is the same. We want to make a temporary magnet without using a permanent magnet, and that is the electrical method. How can we increase the strength of an electromagnet? An electromagnet is the one that is made using electricity. How can we increase the strength? First of all, you need to know the factors that determine the strength of this magnet. The first one is the voltage. So if we want to increase the strength, we need to increase the voltage. Or you can say by increasing the number of dry cells. Then the second factor are the number of turns on the solenoid. The number of turns on the solenoid. So in case we cannot increase the voltage, you make sure that your solenoid has as many turns as possible. So by point number 2, to increase, you have to increase the number of turns on the solenoid. State 2 factors that determine the strength of a magnet made by stroking. In the earlier video, we made a magnet by stroking, and we said the factors are the strength of the permanent magnets, the number of magnets you're using, and the number of strokes. How are magnets useful to the following? Health workers, they are used for removing tiny bits from the patient's eye, tiny magnetic bits from the patient's eyes. To the electricians, they're used for holding screws and nails. In the steel industries, that electromagnet